The costs of contamination. 80% of hydraulic failures come from contaminated oil. Dirty hoses and tubes are a major part of the problem. Today's hydraulic systems operate at higher speeds and are therefore vulnerable to lower levels of contamination. The financial costs from hydraulic failures and other contamination problems are much higher. This means that much more emphasis should be placed on prevention methods. Many other problems from hydraulic contamination can extend far beyond the financial expenses of a repair. For instance, disregarding contamination can lead to invisible declines in operating performance by as much as 20%. That's equivalent to losing one whole day of productivity per week. Extended equipment downtime caused by labor-intensive and outdated procedures, and an increase in repeat system failures caused by contamination. Advancing technology has made contamination a much more sophisticated problem to control. The fluid power industry is changing to accommodate these issues. Manufacturers are now publishing oil cleanliness standards for their machinery and components. They are mandating conformance and rejecting warranty claims for contamination-related failures. But what happens to clean oil when it travels through newly installed hoses and tube assemblies that have not been cleaned? The particles of contamination from the cutting, crimping, bending, and flaring process create a problem that will cause premature wear and system failure. It is imperative to protect your equipment from hydraulic contamination. Premature wear and system failure can be greatly reduced by the installation of clean hose and tube assemblies. To see why, we need a better understanding of what contamination is and how it damages systems. Contamination particles look like this in dirty oil. A microscope reveals actual size differences in appearance between dirty oil and clean oil. But where does such contamination come from? It's often there from the very beginning. Large amounts of contamination are introduced at the time of hose and tube installation on hydraulic machinery. Contamination is generated in hydraulic hose at the time of cutting and crimping. Contamination enters metal tube assemblies during the cutting, deburring, bending, and flaring processes. Hoses and tubes that are not cleaned before installation will have a detrimental effect on any hydraulic system they are being installed on. How do microscopic contaminants achieve such large and drastic effects? Contaminants do not have smooth edges. They are irregular in shape and have sharp edges that cause abrasion as they scrape metal surfaces, creating additional contaminants. Let's follow contaminants in the hydraulic oil as it is drawn from the tank through the hose to the pump. You can see the contaminant's irregular shape with sharp edges and corners. Once the oil and contaminants are drawn into the rotating group of the pump, the contaminants can cause damage in several ways. The larger particles cannot pass through, but will break up as they strike the stationary port plate, shown here in yellow, and cause accelerated wear. Notice how the contaminants break down the edges of the port plate. As we look at other ways contamination can cause problems, we turn the animation of the pump 90 degrees onto its side. Particles can lodge between the piston and the brass slipper foot, shown here in purple, causing it to jam. The contaminants can also scrape walls between the barrel and piston. Electro-hydraulic valves are more susceptible to contaminant damage because the clearances are even smaller, as small as 3 to 4 microns. Some of the particles naturally adhere to the imperfections in the wall or because of the electromagnetic conditions in the valve. This buildup, or siltation, can either slow the spool, causing sluggishness, or make the spool hesitate, causing jerkiness in the system. Over time, the contaminants can cause wear on the spool that results in leakage, and sometimes a large particle can become lodged and block the motion in the valve. All the particles then move onto the filter. Do not assume the filter removes all contaminants in a single pass. As the oil moves through the filter media, many of the particles are trapped, but a few, some large and some small, travel through the media and return to the system through the center tube. Even high-efficiency filters do not remove all contaminants. Contamination can affect any machine with hydraulic capabilities. A hoe that swings too far on a backhoe loader, or one track that runs faster than the other track on a track-type tractor can be a sign of contamination. Equipment owners and operators also see other common effects of hydraulic system contamination, including cylinder drift, jerky steering, slower performance, erratic operation, shorter service intervals, higher operating costs, lower productivity, and possible catastrophic failure. The pump is one of the most expensive components to fix on a hydraulic system. And in the event of a catastrophic failure, it may take days or even weeks to repair a contaminated hydraulic system. That's why it's so important that the means exist today to prevent such problems from occurring. The products and procedures of ultra-clean technologies can protect you from such nightmares. Cleaning procedures. The contamination removal process for hydraulic hoses and tubes just got a whole lot easier and less expensive thanks to ultra-clean technologies. The first step in contamination removal is to make sure that you have a filtered and regulated air or inert gas source. We strongly suggest a 1/2-inch NPT regulator with gauge and a 5-micron air filter to ensure clean, dry air. Dirty, moisture-laden air will defeat the cleaning process by recontaminating your assemblies. Be sure to keep your shop and hose assembly areas clean at all times and always wear safety glasses. When a hydraulic hose is cut with either a metal blade or abrasive wheel, a tremendous amount of heat is generated, along with rubber dust and metal particles. Some of this contamination will stick to the hose tube as it cools. It is vitally important to clean the hose immediately after the cutting process. Connect your ultra-clean launcher and full-flow quick disconnect to a filtered and regulated air source. Load the recommended nozzle and ultra-clean projectile into the launcher's faceplate. Nozzle and projectile sizing charts for hose assemblies, tubing, and pipe are supplied with each unit, along with our recommended cleaning procedures. Now, close the faceplate of the launcher. The safety release bar will lock it into position. Insert the nozzle into the hose. Secure the other end of the hose into the containment barrel or catcher bucket. Depress the trigger until the projectile has exited the opposite end of the hose. Wipe the end of the nozzle clean and repeat this process now through the other end of the hose. The ultra-clean projectile strips out the internal contamination as it travels through the hose and around bends, forcing the contamination out in front of it. When crimping or swaging the end connections onto the hose, do not lubricate the stem of the fitting with lubricants that are not compatible with your customer's hydraulic fluid. This would recontaminate the hose you're cleaning. Use lubricant sparingly and start above the end of the stem. The crimping or swaging process causes stem deformation to achieve the proper coupling retention. Internal metal flash contamination will occur, and it must be removed. A third and final projectile must be fired through the entire assembly to finish the cleaning procedure. You should now use UltraClean's Clean Seal capsules to ensure that the assembly stays clean and contamination-free. Slide the correct size Clean Seal capsule over the end fitting. Place the Clean Seal capsule against the white plunger and push in. If using the UltraClean HL1910E heat gun, move the capped hose end inside of the diffuser. A complete seal takes place in less than 2 seconds. The assembly is now cleaned and protected from contamination. Tube assemblies should also be cleaned to remove metal particles and other contaminants. Before you clean the tube assembly, you should always deburr each end of the tube. Make your bends and flare the end of the tube if required. You should always fire the projectiles from the same end because the JIC and tube nozzle will clean the entire length. If rust or oxidation is present on the inner surface, you may need to use our abrasive projectiles until it is removed. The final projectile through the tube should be an ultra-clean projectile. Repeat the capping process when you're finished cleaning. This Tipco Technologies independent report shows that we can achieve ISO 1310 cleanliness levels when using ultra-clean projectiles and our recommended cleaning procedures. 1310 ISO levels may not be achievable in all hose sizes, styles, and lengths. For more questions about ultra-clean product procedures, please call or email one of our product specialists today.